Now consider one more problem based on the vertical engine in which the weight of piston is also significant and will comes under the calculations of the piston effort. So the problem is a vertical petrol engine of 100 mm diameter and 120 mm stroke has a connecting rod 250 mm long. So the diameter, that is bore diameter, is 100 mm. So I will directly write it as 0.1 meters, and the stroke length is capital L is 120 mm. So in meters it is 1.12 meters, and a connecting rod length is small l is equals to 250 mm. So 0.25 meters. Now the radius of crank is half of the length of a stroke. It is 0.06 meters. Okay. The mass of the piston is 1.1. That is the mass of the piston. That is the mass of the reciprocating component is 1.1 kg. The speed is n, is 2000 rpm. We will convert this 2000 rpm in radian per second as omega equals to 2 pi n by 60, and after calculating this value, omega equals to 209.5 radians per second, 209.5 radians per second. The gas pressure is 700 Newton per meter square, and when the crank radius is 20 degree after just expansion stroke, after on the expansion stroke, that means the combustion or the sparking is at 20 degree radius. I will write here that theta is 20 degree. Again, it is measured from top dead center. Top dead center is equivalent as our inner dead center, and bottom dead center is equivalent as a outer dead center in our horizontal engines. But this engine is vertical, so we are using the terminologies top dead center as well as bottom dead centers. Now the net force on the piston, in this case, you can see here, this is our piston. I'm drawing it with a new color, that this blue color piston is mixed with the black and looks like black, but it is blue. This is the pressure force from the top. At the back side of the piston, the pressure force is neglected because it is approximately equal to the atmospheric pressure. Only top pressure is given, so I am considering the top pressure. This is the pressure force 700 kilonewton per meter square. The pressure is 700 kilonewton per meter square of the piston, and the bore of the piston can be determined by pi by 4 into d square. So the load on the piston due to gas pressure is equal to value of pressure P into pi by 4 into diameter square. After substituting the value of P in kilonewtons per meter square and the value of D in meters, I will get the value of FL as 5.5 kilonewton. Okay, so this is our first value of this problem. I will take this value in a box and use it in the near future whenever required. Now, the piston effort, for the piston effort, there is another force, that is the inertia force acting on the piston. Inertia force is because of the acceleration of the piston when it is moving along this path. And we know that the acceleration of piston is determined by the relation omega square r into cos theta plus cos 2 theta by n. So for this relation, we have to determine the value of n. So n equals to L by R ratio, L by R ratio, L is 0.25, R is 0.06, and after calculating this value, it is approximately as 4.17. 12 by R ratio is 4.17. Now we use this relation of Fi is the inertia force acting on the piston is mr, mass of the reciprocating component, omega square into r, crank radius, cosine of theta plus cosine of 2 theta by n. That's all. After substituting the value of mr as 1.1, omega as 209.5, r as 0.06, cos theta, theta as 20 degree, cos 2 theta becomes cos 40 divided by n equals to 4.17. We can determine the value of Fi, the inertia force acting on the piston at this moment is 3.254 newtons. Okay. This is value of inertia forces. Value of inertia forces. And here at case of I will list as Fi. Now the inertial forces are known to us. The inertial forces are known to us. The load on the piston is known to us. Because of this load, piston is accelerating in the downward direction, and also the weight of piston Wr is supporting the piston to moving in downward direction. Finally, we can write the piston effort. Finally, we can write piston effort as the FL minus, since piston is accelerating, so Fi is taken as negative again, plus FP, plus weight of the reciprocating component. So it is the net downward force acting on the piston, FL minus Fi plus Wr. So the value of FL 5500 in newtons, 5500 in newtons minus the value of Fi 3254 in newtons, 3254 in newtons, plus the value of Wr is mass of reciprocating component is 1.1 into G. Again, G is taken as 9.81 until unless it is stated that to take the value of G as 10, you have to take the value of G as 9.81. G is 9.81, and after calculating these all the values, this summation comes as 2256.8 Newton, and this is our first answer of this problem. So one as the net force of the friction we have to calculate. The resultant load on the gudgeon pin. So the load on the gudgeon pin, the resultant load on the gudgeon pin is the force acting along the connecting rod. That is Fq. Now, Fq is equals to the resultant load on gudgeon pin, which is given by Fp by cos of phi. Now to determine the value of phi, and we know that sine of phi is equals to sine of theta by n. After calculating the value of phi, we get the value of phi as 4.7 degree. If I substitute this value in this relation, then I will get the value of Fq as the value of Fp 2256.8 divided by cosine of 4.7 degree. Cosine of 4.7 degree. And after calculating these values, FQ is equals to, finally we get the value of FQ as 2265 newtons. 2265 newtons. It is very simple to solve the problems based on the forces acting on the IC engines. You can determine the values of all other forces by considering the basic free body diagram of the various components. I shown you the diagram here. Now the thrust force Fn, the third requirement of the problem. This is the answer 2 of the problem. Now the thrust force on the piston, that is also the reaction between the piston and cylinder wall. Third thrust force on the cylinder walls is Fn, and you can write Fn as Fp10 phi, Fp10 phi. The value of phi is 4.7. The value of Fp is 2256.8. After substituting these two values, you can determine the value of 2256.8 and the value of 10 phi, that is 10 of 4.7 degree. So after calculating these values, 185 Newton, 185.5 Newton, the thrust force on the cylinder walls. This is our fourth answer of the problem. Fourth or third? Sorry, it's third one. The fourth one is the speed above which the other things remaining same. Problem is somewhere. The force above which the other thing remains same, the gudgeon pin load would be reversed in the direction. Okay, so we have to determine the speed of the engine at which or above which the gudgeon pin force will reverse in the direction. That means if the gudgeon pin force acting here in the downward direction here as FQ, it suddenly changes its direction. That means it will work in upward direction. So definitely at the speed at which the direction of gudgeon pin force Fp will changes, definitely its sign will become negative. If I am taking this FQ as a positive, then the sign of FQ becomes negative if all the forces are reversed. So first, this is the answer 3. Now, if the FQ is in worst direction, that is, it changes its sign, then Fp also becomes negative, and Fp negative, that means this should be less than 0. And if Fp is less than 0, the relation of Fp we wrote here, that is Fl minus Fi plus Wr should be negative. And if these three forces, summation of these three forces is zero, sorry, less than zero, that is negative, then the Fi has a negative sign. So this quantity becomes negative if the value of Fi is more than these two other values. Simply, we can write here that means the Fi should be greater than in magnitude from these two other quantities, which are Fl plus Wr. You can solve this inequality for this result easily by adding Fi both sides. So you will add Fi here, and from here Fi is cancelled out. So Fl plus Wr is less than Fi. I reverse this relation in this direction here. So Fi is equals to greater than this. If the speed at which the at which or above which the forces on the gudgeon pin changing their direction is n1 and corresponding speed in radian per second is omega 1, then we can write the value of Fi into this relation. I will take this relation with me on the next page. Here. Let n1 is speed of engine above which FQ changes its sign, above which FQ changes its sign. So, and omega 1 is equals to 2 pi n1 by 60. In this case, we can write here that is Fi, which is m r omega 1 square small r cos of theta will be same because we are changing the speed, increasing the inertial force. We are not checking. We are not watching the variation of the inertial forces with respect to the theta. We are watching the variations of inertial forces with respect to the speed of the engine. So theta will be same, remains as usual. Just 20 degree given in the problem. Cos of 2 theta by n should be greater than the value of FL. Again, in case of FL, the value of FL is remains same, does not changes because we are treating the gas pressures are same, the mass of the piston is same, 1.1 into 9.81. Okay, so after substituting these values here, MR is 1.1, omega 1 square R RS 0.06, RS 0.06, and the value of cos theta is cos of 20 plus cos of 40 by n, where n is 4.17. 4.17 should be greater than 5.500 plus 1.1 into 9.81, sorry, 1.1 into 9.81. After all the calculations, we will get omega 1 square is should greater than, or omega 1 should be greater than value of 273 radians per second. The value of n1 after converting this omega in RPM 2606 RPM, and equality remains same. Above this value, above this RPM of engine, the forces on the gudgeon pin changes their direction. Okay, this is the answer for the fourth requirement of the problem. In this way, we can find the forces acting in the various components of the engine. Now we will move towards the turning movement diagram engine. Okay, thank you. If you have any doubt or query related to this particular class or any topic of this subject, you can ask us. You can send your doubts by the WhatsApp or mails at the numbers given below. Thank you.